All right, last example. Buckle in. This one, this is a good example. We'll be here for a few minutes. Um, Find the orthocenter of a triangle. So orthocenters can be found using constructions or coordinate geometry. We are in a coordinate plane, so we're going to use coordinate geometry. Where is the orthocenter of triangle KLM? We're looking for an ordered pair. We're going to be able to find the exact ordered pair where the orthocenter, the three altitudes where they intersect, the concurrency point. So, good news is we can recognize that your three altitudes will intersect at one point. So, really, it's good enough to find two altitudes and see where they intersect because that third one will hit at that same point. So we're going to find our two altitudes. We're going to find two of the three. So we're just going to find two altitudes and then we're going to find where they intersect. So we're bringing in a lot of algebra on this one. So let's go through. We'll just do this step by step. We're in this together. So step one, we want to find the slopes of two sides of our triangle. So let's find the slope of KL. And let's also find the slope of ML. If you notice, we're not using side KM, and that's okay. We just picked two sides. We're going to find the slope of each side. We could have used MK in there if we wanted to, but we just picked the other two. All right, so the slope of KL from K to L, we can find the slope by just counting the rise over the run. As long as you start with the point on the left and you do the rise first. So we're going to rise 1, 2, 3, 4, 5. We're going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the slope of KL had a rise of 5 and a run of 10, so 5 over 10. We do want to reduce that to 1/2. All right, let's do the same thing for ML. Start with the point on the left and do the rise first. So in this case, the rise is going down, so it will be negative. But let's count down 1, 2, 3, 4, 5, 6, 7. So that's going to be a -7, and our run is 1, 2, 3, 4, 5, 6, 7. So the slope of ML, our rise was a -7, and the run was a 7, and that will reduce to a -1. All right, so step one wasn't too bad. Step two, we're going to write the equations of the altitudes. So the altitude of segment KL, so here is KL, the altitude will be perpendicular to KL. So that's why we had to find the slope of KL, so we would get a perpendicular slope. So the altitude of KL will have a slope equal to, now the perpendicular slope to 1/2. Perpendicular slopes, we learned this in a previous unit, opposite reciprocal. So flip it and change the sign. We'll have a slope of -2, and it will go through point M, which is 312. So let me just show you what we did there. So KL has a slope of 1/2. The altitude of KL will have a perpendicular slope, so -2, and it's going to go through the opposite vertex. So it's going to go through point M. So point M, 312, with a slope of -2 will give us the altitude of KL. So that's enough information to write an equation for this altitude. We're going to follow our y equals mx plus b form. We have an x and a y from the ordered pair, and we have a slope of -2. So let's plug in those values so we can solve for our y-intercept. So our y is 12 equals our slope is -2 times the x is 3 plus, I'm going to make this a capital B right now. Sometimes my b's look like sixes, so I just don't want to get confused. We're going to solve for b. So 12 equals -6 plus b. Let's go ahead and add 6 to both sides. So our y-intercept is 18. So the equation of the altitude of KL is y equals -2x plus 18. That's a lot of work we just did. I'm going to kind of circle that so we know to come back to that. We have to write an equation for the other altitude. So here, I'll switch colors just so we don't get it mixed up. So now we need the altitude of ML. So the altitude of ML will have a slope equal to, now let's go back up. We found the slope of ML to be -1, so we need the perpendicular slope. So if you flip that and change the sign, the perpendicular slope will be +1, and it will go through the opposite vertex, which is K, 0, 0. So let me just show you in the picture what we're talking about. The slope of ML, oops, first we found the slope of ML. Now we want to write the equation of the altitude of this. So we need the perpendicular slope to ML, which is a +1, and it's going to go through the opposite vertex, which is K. So we're going to have a line going through K, hitting the opposite side with a slope of 1. That will be perpendicular. That will be an altitude. So let's follow the same math we did before. We can just use our y equals mx plus b format, plug in our x and our y and our slope, and solve for our y-intercept. So 0 equals, our slope is 1 times our x is 0 plus, again, I just like a capital B so I don't get confused. 0 equals 0 plus b. So pretty much our y-intercept is 0. So this equation is y equals 1x plus 0, or just y equals x. All right, you guys still with me? Step 3. Step 3 is to find the intersection point of those two altitudes we just found. So what we'll do is we'll put those together as a system of equations. You guys have not done this since algebra. So our first equation was y equals -2x plus 18. The second one is y equals x. We create a system of equations that we can solve to find the point where these two intersect. So you guys learned how to solve systems in algebra using substitution or elimination. This one is set up really nicely for substitution. We know that y is equal to x, so all we do is we say, well, if y equals x, this x will get substituted into the other equation for any y's. There's just a y right there, so we're going to rewrite this and replace that y with an x. So x equals -2x plus 18. What that does is it gives us an equation in one variable. We can actually get our x's together and solve. So let's add our 2x to both sides. That gives us 3x equals 18. Divide both sides by 3, so x equals 6. We're looking for an ordered pair. We just found the x value. Now the y value we get by just taking this 6 and plugging it back into either equation. You could plug it in for this x or for this x. The bottom equation, y equals x, is pretty easy to plug into. If you plug in a 6 for that x, well, look, we just figured out that y is also a 6. So this ordered pair, where our two altitudes intersect, is the orthocenter of the triangle. So if we go back up I'm going to plot that point 6, 6, just so we can see a visual of what it is. So over 6, up 6. This is the point where all three altitudes would intersect. If I were to sketch in the altitudes, so here's the altitude of one vertex, here's the altitude of another. See how it's hitting our opposite sides at right angles? Here's our last one. So yeah, that 6, 6 makes sense. It looks accurate with our picture. All right. Nice job, you guys. Sorry that was a long video.